Hi, I'm Ms. Wong. Let's have a look at parallel and perpendicular lines. Here we have parallel lines. We have the equation y equals 2x and y equals 2x plus 4. So we notice that when lines are parallel, the gradients are the same. So we might call these gradient 1 and gradient 2, or gradient A and gradient B. So let's call it m of A and m of B. So when they're parallel, we say the gradients are equal. Let's have a look at these two lines. Here we have y equals 2x and y equals minus a half x. We can clearly see that these two lines are perpendicular. Now the gradient for this one is 2, the gradient over here is minus a half, so they're not the same gradient, but we notice that when we multiply 2 times minus a half, we get minus 1. The gradients of perpendicular lines always multiply to give me minus 1. So you'll see the formula as m of A times m of B is negative 1, or sometimes you'll see as m of 1 times m of 2 equals negative 1. So parallel lines, you have the gradients to be the same. Perpendicular lines, the gradients multiply to be negative 1. Example 1. Here we have a few equations. Let's see which pairs are perpendicular and which pairs are parallel. The gradient here is negative 3 and a third, so they're definitely not parallel because they're not the same. But negative 3 times a third is negative 1, so these two lines are said to be perpendicular. Let's have a look at these two equations. We can see that they are not in gradient intercept form, so let's rearrange them. So bringing the 2x over the other side becomes negative 2x, so the gradient for this line is negative 2. And this one, let's bring the 4x to the other side, and we still have to divide by 2 to get rid of that 2. So dividing by 2, we get y equals minus 2x plus 5. Now looking at the equations rearranged, we can see that the gradients are the same. So these two equations are parallel. Example 2. Find the equation of a straight line which passes through the point 1, 2 and is parallel to the line with the equation y plus 4 equals negative 2, and part B, perpendicular to that line. Let's do part A first. So parallel means, well, firstly we have to find the gradient. So we have to rearrange this equation. So bring the 4x to the other side to find m. So bringing 4x to the other side, we get minus 4x, so m is minus 4. Now in part A, we want a line that is parallel to this line, which means we want it to have the same gradient. So our gradient is minus 4. And passing through that point would mean that we would plug that point into that equation and our gradient into that equation, and we can solve for it. Be very careful that minus 4 times minus 1 is positive 4. And bringing the minus 2 to the other side, we get plus 2. So now we have y equals minus 4x plus 6. So this line that we came up with is parallel to that line that they've given us. Part B, perpendicular, or in other words, MA times MB equals minus 1. So to find my gradient, I would have to take that gradient, bring it to the other side, and I would get minus 1 over the other gradient. So now we have M equals to minus 1 over the other gradient, which is minus 4. So minus and a minus becomes positive. So write this formula down also, where our gradient, when it's perpendicular, it's minus 1 over the other gradient. So now that we have the gradient and the point, plug it into the same equation, that one there. So the point is 1, 2, so 1, 2, and the gradient is a quarter. Now we have to expand and simplify. So times the quarter across, and then bring the 2 over, becomes positive 2. 2 minus a quarter is 1 3/4. Example 3. Given the 3 points A, B, and C, show that the line joined in the points AB is perpendicular to the line AC. Now to show something is perpendicular, we don't have to find the equation of the line, we just have to find the gradients, and that the gradients will multiply to give me negative 1. So this time, notice that I've changed the formula. Instead of writing MA, I'm writing MAB to refer to the gradient of the line AB, and MAC to refer to the gradient of the line AC. So we can always change the subscript to suit our story so it's easier to refer to. So let's find MAB, or in other words, the gradients between A and B. So we would use the formula. So plug the numbers in, 3 minus -1 and 2 minus 0, which gives us 3 plus 1 is 4 over 2, which is 2. So MAB is 2. Now we have to find M of AC. So M of AC is those values over there. So minus 2.5 minus -1 over 3 minus 0. Minus 2.5 minus -1, which is plus 1, is minus 1.5 over 3. And so we get -1/2. Now let's multiply the two gradients together. 2 times -1/2 is -1. Therefore, the lines AB and AC are perpendicular to each other. Just a quick highlight, because it says show, you have to use that formula and show that it's actually -1. So I've actually multiplied it through. I didn't leave my answers as that gradient and that gradient. I've shown that they multiply to give me -1. So make sure that you do that whenever the question is asking for you to show something. And don't just stop at the gradients, otherwise you'll lose some marks. Thank you for watching, and I'll see you next time. Bye!